Dear all, good morning. Today, I'm going to discuss regression analysis in STATA. There are several types of regression analysis like linear regression, logistic regression, Poisson regression, log binomial regression, negative binomial regression, etc. But today, we'll discuss linear regression. But question, when do we use linear regression? Generally, if the outcome variable is continuous or quantitative, in this situation, we have to use linear regression. If we open our data already in the video description, I have given the link. Please download the example data for practice purpose. Here, two variables B are browse, maternal weight and maternal height. Two variables are continuous. But remember, please, if outcome variable is continuous, then we can use linear regression. So, for example, our objective is to assess the relationship between maternal height or maternal weight. Here, if we use regression analysis, then obviously we have to identify which is dependent and which is independent variable. Obviously, maternal weight, this is dependent variable because weight, you know that weight depends on height. So, first of all, we have to use scatter plot. And using scatter plot, primarily, we can identify the type of association. It is positive or negative, or there is no relationship, or not a linear relationship. So from this graph, it is clearly mentioned that there is a strong correlation between maternal height and maternal weight. That means if the maternal height will be increased, then maternal weight also increase based on this scatter plot. Now, we can assess the correlation. Just correlation, CORR, correlation. Already we have discussed in the previous session. So, in the correlation analysis, the correlation coefficient is 0.4. This is if the correlation more than 8, then we can say that there is strong correlation. But this is significant or not, just we have to type pwcorr and seek this p-value, and it is clear that the p-value is highly significant. So obviously we can use regression analysis. Remember, please, to analyze the regression, first of all, we have to assess the correlation. If the correlation value is significant, then we can use regression analysis. And in the regression analysis, there are two types of variable. One is dependent, one other is independent. Already I have mentioned. And we know that the maternal weight dependent variable or any weight is depend on height. So the syntax is maternal weight and first dependent variable, and the main benefit of STATA is syntax. The syntax is very easy. For this reason, always I recommend to use STATA. But obviously, who are very skilled at data analysis, I suggest that please use R programming, because if we use R, then we can save our time. But for a new person, those person who are new in data analysis, I recommend that person please use STATA. This is our syntax. So what's the interpretation? First of all, we have to see the R square value. The value of R square is 0.17. That means the dependency rate 17%. That means maternal weight depends on height by 17% and it is significant. Then coefficient. This means, this is completely hypothetical. This means if maternal height was 0, then weight was minus 65 kg. Is it possible? It's not possible, but this is the definition. Since maternal weight doesn't 0, so we cannot interpret this value. But remember, please, there are some value where 0 value is possible. Then we can interpret if the independent variable is 0, then the dependent value is constant value. Here, the constant term is minus 64. So we can say that if maternal height was 0, then weight was minus 64. It is not possible. Just for learning purpose. The main interpretation is this. This is the main interpretation. That means this value. This value. What is the interpretation? The interpretation, if maternal height was increased by 1 centimeter, because the unit is in centimeter, then weight was increased by 0.778 kg. This is the interpretation. And the p-value is significant. Confidence interval, that means the strength of association. That means since the interval doesn't contain 0, then we can say that it is also significant. And the confidence interval will be very small, then the association will be strong. This is the interpretation. So we can use another variable, that means, okay. So if the number of independent variable is 1, then it is called the simple linear regression. Simple linear regression. If the independent variable more than 1, then it is called multiple linear regression. For example, if we use another variable, maternal height, maternal age, this is age. Yes. If maternal age was increased by 1 year, then maternal weight also increased by 0.35 kg, and it is also significant. Then main problem when dependent variable is category, for example, type of residence, this is a category variable, or tab, division, this category variable. Then how to adjust? Remember please, for category variable, just we have to type I dot the rural. So tab null, 1 means urban, 2 means rural. Then if we numlabel comma at, if we use this command, then we can see value as well as label. Okay. So for regression analysis, when dependent variable is a category or qualitative, then we have to guess a reference variable. So if I type I dot, then lower value will be reference, but our interest to give rural is reference. Then we have to type B2, just IB2. IB2 means 2 is reference. Yeah. Then what is the interpretation of this value? The interpretation value is the average. The average maternal weight was 3.5 kg more in urban mother than rural mother. Please don't mind for my grammatical problem. Sometimes there was some grammatical problem, but there is another issue. So this is the interpretation when the dependent variable is category. If we use another dependent variable, for example, wealth index. 1. So the category of wealth index, poorest, poorer, middle, research. Then if 1 means this is reference. So if we type, okay, the average maternal weight was 10 kg more in research household. The average maternal weight was 10.8 kg more in the researched mother then reference is poorest mother. Then poorest mother. So for this value, the average maternal was 5.5 kg more in the richer mother than poorest mother. Always we have to compare with poorest because the reference is poorest. So this is called the simple linear regression if the independent variable is 1. But if independent variable is more than one, then it is called multiple linear regression. it is called multiple linear regression. Why multiple regression? Because the number of independent variable is more than one. So if we use linear regression, then we have to test the diagnostic, regression diagnostic, because there are some assumptions. The main assumption is heteroscedasticity. So if after running the full regression model, we have to test is called hettest. This is the estat hettest. Significant means what is the interpretation of this value? Assumption, normal error turn, verified value of this is called constant variance. That means our assumption is constant variance. So p-value is significant means constant variance assumption violation. But remember, please, there is a problem of regression analysis. If the sample size will be large, then maximum diagnostic test will be significant. In this situation, obviously, we have to use graphical representation. How to check the graphical representation? Just we have to type predict. This is the main function, and this is we can use this any variable. So okay, then there is a standard residual. There was a variable. We have to use hist this variable. The error term is normality statement. That means normality assumption is hold. Another important term is this is the one kind of mandatory diagnostic test. If we get there is a parallel graph in the middle of the scatter plot, this is fitted value, residual versus fitted value. Scatter plot between residuals and fitted value. If there is a constant relationship, then we can say that the homogeneity assumption is hold. Another is leverage value, then Cook distance. If the sum, if any value of Cooks greater than 1, then we can say that there is a outlier. Then the important diagnosis is VIF. If any value of VIF greater than 5, then we can say that there is a multicollinearity problem. So if we get multicollinearity, then we have to drop this variable from this model, or we have to composite between two variables who are highly correlated. So these are from the linear regression. So it is very difficult to discuss details. Just I have discussed based on my data set. So if you would like To learn more, then obviously you have to read some article or book. Thank you very much.